Hi, this is Stephen Haynes from Haynes Fire and Risk Consulting. I'll be presenting Rural Water Supply in the 21st Century, Part 6, the concept of continuous water. In Part 6 of the program, we're going to review the concept of continuous water, or define it. We're going to discuss why rural firefighters typically don't use continuous water supplies until it's too late, discuss traditional strategies for obtaining a continuous water supply, and we'll talk about some 21st century tactics for obtaining continuous water. A continuous water supply is one that meets your needed fire flow and can be established in a timely manner without interruption, and it can be sustained over a recommended duration. If you go back to part 2, I believe, of our presentation, we talk about needed fire flow. This isn't a new concept. There's really no class or book on general firefighting tactics or engine company operations. It doesn't tell you need to establish a continuous water supply whenever you can. And it's a safety issue too. We need to get these water supplies established because it's not just a success issue of whether we get the fire put out or not. It's a safety issue. We got people in a building, we have an interruption of flow, we have people at risk. We need to stop this. We need to minimize the potential for flow interruptions. Also, a continuous water supply gives us a better opportunity to make up for mistakes that we make in our tactics and strategies. As the incident commander, we can't see everything going on inside the building, and our 500-gallon-a-minute fire can easily become a 700-gallon-a-minute fire because we chose the wrong option. So we need the continuous water supplies to give us a better error or better margin of error. The other thing too is even a partially adequate water supply, even if we can't get our full needed fire flow, is better than no continuous water supply because it provides us a buffer against flow interruptions, improving fireground safety, and it could allow us to hit a higher peak rate when we really need to push things and get that final knockdown. And also the other thing is it can help to reduce the number of drivers you need by increasing your gallons per driver ratio, as we discussed in other parts of the program, by orders of magnitude by simply getting that continuous water supply into operation. So if there's so many benefits to establishing a continuous water supply, why are they often never implemented or they're implemented too late? And I can tell you there's a couple of reasons behind this. First, traditional methods require a lot of coordination, time, manpower, and apparatus to get established. All of these things are in short supply today, and particularly during daytime hours. The cleanup time is often considered to be unjustified compared to the size of the fire. Overuse can be perceived as crying wolf or a sign of weakness. I'll tell you right now, the fire chief who runs 5 tankers on every structure fire, reported structure fire, is probably being looked at sideways by the chiefs in the neighboring districts. So if we take a moment to read between the lines, what this is really telling us is our traditional methods of establishing these water supplies are inefficient and are not very reliable. So we have a tendency when we're dealing with inefficiency and unreliability is we don't want to do these things unless we really have to. We're going to talk about this reliability issue a little further. So what I've done here is I set up 2 columns. On the left here I've listed our traditional methods of getting a continuous water supply established by their order of reliability. Obviously, pumping directly from a pressurized source is your most reliable. This is what the inner city and your suburban fire departments do every day. They don't even think about putting a pressurized water source into place. It just happens every day. Relay pumping from a pressurized source, where we have to get a couple extra pumpers, 1 or more pumpers in the middle of the line. It's a little more harder to set up, but it's still very reliable because we're using fire hydrants in many cases, or a pressurized source. Pumping directly from a drafting source is probably in there number 3. The problem is in many of our cases is we don't have a pond or a drafting hydrant right in front of the property, that there's almost always going to be a relay involved. So anytime we add more vehicles to our operation, we're going to increase the complexity. If we go from a pressurized source to a drafting source, we're going to increase the complexity. When we get to a tanker shuttle, the next most complicated thing is we got multiple trucks running multiple routes, probably with multiple loops, multiple dump sites, multiple fill sites. And if we're using pressurized sources, at least we've eliminated the drafting issue. And probably the least reliable of all these methods is the tanker shuttle that's being supported by drafting operations. The problem is then we go over here and we look on the right hand side and we list these things by the typical frequency of use from most to least. And what you end up looking at is the top 3 things that we do on a regular basis in the rural environment are our most least reliable methods of getting a continuous water supply into place. These are the types of things that have the most number of steps, the most number of pieces of equipment, which rapidly increases the chance of a hiccup or a failure or a difficulty on the fire ground. Let's talk about this further. So what I've done here is I've reorganized our list of frequency by use, and I truly think that if we put some 21st century thinking, technology, and hardware into use, we could get to where our top 3 go-to water supply operations become much more reliable, and we can start moving these drafting operations down. And the whole key to this, I really believe the key to getting us into the 21st century is to eliminate or at least minimize the need for drafting on the fire ground as much as we can. Drafting operations, no matter what you do, are complicated. It takes people that needs a touch. You need people to have a lot of experience to do it reliably. You need equipment that's top notch. The slightest vacuum leak can knock you off your game. I really think that we need to get drafting out of our operations as much as we can. So let's talk about this reliability stuff even a little. So what I've done in this slide is I've listed the most common reliability issues out there. First is skills and knowledge. The more complicated the operation, the more of a touch do you need to get it done, the higher the skill level. Not everybody's going to be able to do some of these things. Vacuum tightness. Especially when you're doing drafting, vacuum tightness is the key. Valves got to be closed, valves got to be in good condition, gaskets have to be in good condition, everything's got to be tight. Access to water is a reliability issue. With drafting, the pumper's got to typically get within about 18 to 20 feet of the edge of that water at the most. Even if you get into the air priming systems to advertise 100 feet of suction hose, how many people have enough room on their trucks to store 100 feet of suction hose and put it into service quickly? Pumping lift. Pumping lift is an issue. The higher the lift is, the less reliable drafting becomes. The other thing about pumping lift is it reduces our capacity. Once you get to about, say, 13 to 16 inches of mercury, your pump is done. You've hit the maximum flow rate you're going to get from it, and you're not going to be able to do anything else with it. It's just the way centrifugal pumps work. Ice and vegetation are always an issue when we're dealing with static water sources. Ice keeps us from getting into the water. Vegetation keeps us from flowing. Apparatus intensity. How many vehicles do we need to get the job done? And the other one is driver intensity. And when I say driver intensity, I mean drivers who are qualified to safely operate large vehicles. Let's face it, not everybody out there can handle a large vehicle safely. And there's some guys who can't handle emergency driving safely, let alone a large vehicle. Manpower intensity. How many extra people does it take to set that operation up? And generally, I look at it as it takes one guy to put a fire hydrant into play. So when I say it's intense, it requires more people than a fire hydrant. We're probably never going to eliminate that one in the rural water supply environment. Traffic and roads. One of the big things to deal with is, especially when we get into tanker shuttle operations, is how much traffic's on the road, what's the configuration of the roads, the bridges, the tunnels, all those things that come into reliability. So what I've done here is I've kind of listed what I think the key reliability issues are with direct pumping operations from a drafting, the key things for relay pumping. And the reason I've listed these as a smaller letter here is I want them to be, they're not quite as critical. They're there, but they're kind of a soft reliability issue. And tanker shuttles. And you can see when you get into a tanker shuttle, you've brought all the complexity, all your reliability issues into play. What we're going to talk about next, and I want to introduce you to, is high transing. In high transing, you'll see that we've really eliminated a lot of our vegetation, a lot of our reliability issues, I should say. The one thing that's going to always be there is ice and vegetation. But what we're going to do is we are going to have some manpower reliability issues because we need more people to put a high transing operation into place than a fire hydrant. But one of the things about it is it's more reliable and quick to put into service. So those people are freed up sooner. So that's why I've gone with a lowercase h here. And I, under the tanker shuttle, why I've mentioned that here is if I use high transing to move my water supply to where the tanker loop is more efficient and shorter, I can increase the effectiveness of that operation. So traffic and roads might still come into play here if you're using high transing to support a tanker shuttle. In the next slide here, let's talk about what the heck high transing is. So in this slide, we're going to define what high transing is. And basically what it comes down to, high transing is the practice of using a remotely powered submersible pump to pump water directly from a static water source. In this picture here, the Slanesville Fire Department in West Virginia has a unit with a hydraulic power unit in the back. When they arrive at the water hole, they pull a submersible pump and bring it over to the edge of the pond. The submersible pump is supplied by these hydraulic hoses, which are on a reel, so that they're easily deployed for emergency operations. You connect your water supply hose to the pump, you throw the pump into the water, start the engine, and now you're high transing. The biggest thing here is there's absolutely no vacuum priming required. The slightest leak is nothing more than a water leak on a fire hydrant or a fire hose. Everything is under pressure. That's high transing. So high transing is relatively new art in the United States, although it's been around since 1988 outside of the country. It offers several benefits that we ought to be taking advantage of. The biggest one is there's no vacuum priming required. Now we have the opportunity to operate regardless of lift at a pond or a creek or whatever other water source. If the unit can reach it with a hydraulic hose, which typically are anywhere in the area of almost 100 to 200 feet long, we could put that water source into play, whether we're talking vertical lift or we're talking horizontal reach. There's no loss of pump capacity at high lifts because the pump is in the water and it's working under pressure. There's no longer a delay in our firefighting operation because we're running around trying to figure out where the vacuum leak is or trying to deal with vacuum primers that aren't working properly. So we can get into service a lot faster, a lot more reliably. The biggest thing here is the truck or the power unit does not need to get close to the water source because we've got the horizontal reach of our hydraulic hoses. I'd like to give you a challenge. Drive around your response district and look off to the sides of the road and look for those water holes that are anywhere from 50 to 100 feet off the edge of the road and start taking an inventory of them. And I think you'll be surprised that if you had a pump that you could drag over there and move a large volume of water from it, how many new water sources you have in your district. The other thing about these high trans pumps is they have high flow and pressure capacities. Typically we can fill tankers at any kind of rate from about 1,000 to 2,000 gallon a minute depending on the unit you have. They also have a high enough pressure rating that you could use them to supply the fire ground directly, or you could use them to feed a hose relay. And like I said, the biggest thing here is because we're using trucks other than pumpers, is we're able to free these pumpers up and the personnel on them to be used at the fire ground. So I'd like to wrap up our presentation on 21st century water supplies with a summary. We can improve fire ground success rates and we can improve firefighter safety on the rural fire ground by adopting 21st century practices. The first is we need to use realistic needed fire flow rates. We need to reserve NFP 1142 fire flow rates as our bare minimum. We got to recognize that when we're operating at a bare minimum water capacity, these operations are risky and they're less likely to be successful. We need to implement tactics early on to concentrate water up front. We need to concentrate our water up front because it maximizes our early on fire flow rates and it minimizes the potential for flow interruptions. Remember, anytime the hose line goes dry, we've got people at risk. We need to implement tactics and equipment that will allow fire ground operations to transition to continuous water supplies early on and as part of every firefight. It should be a natural transition in our firefighting operations that the supplemental continuous water supply is starting to wind up as we're working on the fire grounds. If we don't need it, we can stop putting it into play. But we really need to get to where we're putting these continuous water supplies into operation on a regular basis. And the last thing is we need to improve water supply operations by eliminating drafting wherever possible. It's cantankerous, it requires a lot of skill and can eat up a lot of time on the fire ground. Drafting is one of the biggest problems we have in the rural fire service. The last thing I want to mention is about high transing is that it not only eliminates drafting, but it can open up new water holes, as we talked in the other slide. And the other thing it could be used for is even with tanker shuttle operations, is if we use high transing to move the water to where the tankers can easier get to it and shorten the loop, we're going to increase our water flow rates and the level of reliability of our tanker operations. Once again, this is Steve Haynes from Haynes Fire and Risk Consulting. I hope you found our presentation useful. I hope to hear your feedback. Thanks for joining us. Please tune in later for other videos where we're going to start talking about some of the different technologies. Hopefully we'll get away from this boring PowerPoint format and we'll actually get some videos involved for you as well. Take care.